National Electrical Code, specifically Section 430.95, addresses the location of disconnecting means for motors. Subsection B states that where the disconnecting means is located within sight from the motor location, it is generally compliant. However, there are exceptions to this rule. A single disconnecting means may be used to disconnect a group of motors under specific conditions. Firstly, the disconnecting means must be in sight from the motors and identified for each motor disconnected. This means that the person operating the disconnect must be able to see all the motors it controls, and there must be a clear indication of which disconnect corresponds to which motor. Secondly, the disconnecting means can be part of a listed multi-motor control device. This typically applies to factory-assembled control panels where multiple motor starters and disconnects are integrated into a single unit. Thirdly, for a motor used for non-hoisting elevator, the disconnecting means is acceptable if accessible to qualified personnel. Finally, the motors do not drive a single disconnecting means is readily accessible to qualified personnel. In the situation you described, where the motors are located within 30 feet and the MCC disconnects are within sight of all motors and identified for each motor, it appears to be in compliance with the NEC based on the information provided. The key requirement is that the disconnects are clearly labeled to indicate which motor each one controls. This ensures that personnel can safely and effectively disconnect power to the appropriate motor when needed. It is essential to ensure clear identification for each motor's corresponding disconnect within the MCC. Proper labeling is crucial for safety and compliance. Failure to properly identify the disconnects could lead to accidental disconnection of the wrong motor, creating a potential hazard or disruption. Always refer to the latest edition of the NEC and consult with a qualified electrical inspector to ensure compliance with all applicable codes and standards. The NEC is updated regularly, and interpretations of specific sections can vary. Therefore, relying on the latest version and seeking expert advice is crucial for maintaining a safe and compliant electrical installation. It is also essential to consider any local amendments or regulations that may supplement or modify the NEC requirements. Local jurisdictions may have specific rules or interpretations that must be followed. Always check with the local authority having jurisdiction AHA to ensure full compliance. In addition to the NEC requirements, it is important to follow safe work practices when working with electrical equipment. Always de-energize and lock out the disconnecting means before performing any maintenance or repair work on the motors or associated equipment. Use appropriate personal protective equipment (PPE), such as insulated gloves and eye protection, to minimize the risk of electrical shock or arc flash. Regular inspections and maintenance of the MCC and motor disconnects are also essential for ensuring reliable and safe operation. Check for any signs of damage, corrosion, or loose connections. Repair or replace any defective components promptly. A well-maintained electrical system is more likely to operate safely and efficiently. Also consider the working space requirements around the MCC. The NEC specifies minimum clearances for working space around electrical equipment to provide adequate access for maintenance and inspection. Ensure that the working space is clear of obstructions and that personnel have sufficient room to safely perform their tasks. Furthermore, consider the ambient temperature and ventilation of the MCC room. Excessive heat can damage electrical equipment and reduce its lifespan. Ensure that the MCC room is adequately ventilated to maintain a reasonable temperature. Consider using cooling fans or air conditioning if necessary. The NEC also addresses the overcurrent protection requirements for motors. Each motor circuit must be protected by an appropriate overcurrent device, such as a circuit breaker or fuse, to prevent damage from overloads or short circuits. The size of the overcurrent device must be carefully selected based on the motor's full load current rating and other factors. Proper overcurrent protection is essential for preventing motor failures and electrical fires. Also, the type of motor starter used can affect the disconnecting means requirements. For example, some motor starters include built-in disconnecting means, while others require a separate disconnect. Ensure that the motor starter is properly rated for the application and that the disconnecting means is compatible with the starter. When selecting motor disconnects, consider the voltage and current ratings of the motors being controlled. The disconnects must be rated to safely interrupt the maximum available fault current at the motor terminals. Using undersized or improperly rated disconnects can create a safety hazard. Consider the environment in which the MCC and motor disconnects are located. If the environment is harsh or corrosive, select disconnects that are specifically designed for those conditions. For example, disconnects with NEMA 4X enclosures are suitable for use in wet or corrosive environments. Regular training for personnel who operate and maintain the MCC and motor disconnects is essential. Ensure that personnel are familiar with the NEC requirements, safe work practices, and the proper operation of the equipment. Training can help to prevent accidents and ensure that the electrical system is operated safely and efficiently. Also, document all electrical work performed on the MCC and motor circuits. Maintain accurate records of inspections, maintenance, repairs, and modifications. This documentation can be helpful for troubleshooting problems and ensuring that the electrical system is properly maintained over time. Consider using a power monitoring system to track the performance of the motors and electrical system. Power monitoring systems can provide valuable data on energy consumption, motor loading, and other parameters. This data can be used to identify potential problems and optimize the performance of the electrical system. When making any changes to the electrical system, always consult with a qualified electrical engineer to ensure that the changes are properly designed and implemented. Improperly designed modifications can create safety hazards and violate the NEC requirements. Also, perform regular arc flash hazard analyses to assess the potential risk of arc flash incidents. Arc flash hazard analyses can help to identify areas where arc flash protection is needed and to select appropriate PPE for personnel working on the electrical system. Consider using remote monitoring and control systems for the MCC and motor disconnects. Remote monitoring and control systems can allow personnel to monitor the status of the equipment and control it remotely from a safe location. This can be especially useful in hazardous environments. When installing new motor circuits, ensure that the wiring is properly sized and installed in accordance with the NEC requirements. Use the appropriate type of conduit and fittings for the application and ensure that the wiring is adequately supported. Improperly installed wiring can create safety hazards and violate the NEC requirements. Furthermore, consider the use of surge protection devices to protect the motors and electrical system from voltage surges. Voltage surges can damage electrical equipment and cause premature failures. Surge protection devices can help to mitigate the risk of voltage surges. Also, consider the use of harmonic filters to reduce the level of harmonic distortion in the electrical system. Harmonic distortion can cause overheating of electrical equipment and reduce its efficiency. Harmonic filters can help to improve the power quality of the electrical system. When selecting motor disconnects, consider the ease of operation and maintenance. Select disconnects that are easy to operate and maintain and that have readily available replacement parts. This can help to reduce downtime and maintenance costs. Perform regular thermographic inspections of the MCC and motor disconnects to identify any hotspots. Hotspots can indicate loose connections, overloaded circuits, or other problems. Thermographic inspections can help to prevent equipment failures and electrical fires. Also, consider the use of ground fault protection devices to protect personnel from electrical shock hazards. Ground fault protection devices can detect ground faults and quickly de-energize the circuit, reducing the risk of electrical shock. When working on energized electrical equipment, always follow strict safety procedures and use appropriate PPE. Only qualified personnel should work on energized electrical equipment, and they should be thoroughly trained in safe work practices. It's also important to have a written electrical safety program that outlines the safety procedures and requirements for working on electrical equipment. The electrical safety program should be regularly reviewed and updated to ensure that it is effective. Consider the use of adjustable speed drives (ASD) to control the speed of the motors. ASD can improve the efficiency of the motors and reduce energy consumption. However, ASD can also generate harmonics, so it is important to consider the use of harmonic filters when using ASD. Ensure that all electrical equipment is properly grounded in accordance with the NEC requirements. Proper grounding is essential for preventing electrical shock hazards and ensuring that overcurrent devices operate properly. Also, consider the use of uninterruptible power supplies UPS to provide backup power to critical motors and equipment. UPS can ensure that critical equipment continues to operate during power outages. When selecting electrical equipment, consider the lifecycle cost of the equipment. The lifecycle cost includes the initial cost of the equipment, as well as the cost of maintenance, repairs, and energy consumption over the life of the equipment. Consider the use of energy-efficient motors to reduce energy consumption. Energy-efficient motors can save significant amounts of energy over their lifespan. It is also essential to have a regular electrical safety audit performed by a qualified electrical safety professional. The electrical safety audit can help to identify potential safety hazards and ensure that the electrical system is in compliance with the NEC requirements. Remember to properly label all electrical panels and equipment. Clear and accurate labeling is essential for safety and for troubleshooting problems. Conduct routine inspections and preventative maintenance on all electrical equipment. Regularly scheduled maintenance will help to prolong the life of your equipment and reduce the likelihood of unexpected failures. Adhering to all these guidelines, and specifically to the aforementioned NEC Section 430.95, will ensure compliance and maximize safety, the two crucial aspects of any electrical project.